Guys, today we're going to be talking about partial quotient algorithm, which is a fancy word if you think about it in pieces. Partial means in pieces or in small amounts. Quotient is the answer to a division problem. So we're going to be solving division problems by looking at it in pieces to come up with our total answer. Now, we're going to actually look at two different examples of how to do this. The first example will be a problem that doesn't have a remainder. This is the first type of division your scholar learns. It's going to be the easiest for them. The second we're going to look at is remainders. It's not necessarily harder, but it can be confusing trying to figure out what to do with the remainders. Now, the first problem, our one without remainders, is going to be 236 divided by 4. Now, if you notice when I set this up, it starts out looking exactly like what we would have learned in school years ago, except it's got this weird tail. This is actually a bar that helps you divide the different pieces of what you're dividing. We actually divide by using multiplication. Now, before we can do any of the solving, we actually have to write what's called quick facts. Quick facts are used as simple numbers our brain can come up with for multiplication facts that could be used to go into this problem. Quick facts are not designed to be something high stress. If you do some research and some investigation on this strategy, you'll notice that different teachers do different quick facts. I'm going to show the quick facts that I normally use in my class. Quick facts are just meant to be numbers we can think of. So for my scholars, we know that our quick facts are all going to start with that 4. It's going to be 4 times something. So we're going to have 4 times, I'm going to do it in a couple different colors. 4 times 0. Oops, I forgot my different colors. 4 times 0. I include the 0 because it helps us know when we're done with our problem. Then we have 4 times 1. 4 times 2. Man, forgot it again. 4 times 3. I include this 3 because it helps when we get down to smaller numbers. This 3 is one that a lot of teachers don't include. It's okay if you choose not to do this in yours. Then we're going to go to 4 times 5. After 4 times 5, we've got 4 times 10. Notice we didn't get all bogged down to the times 8 and times 7. Those aren't facts our brain easily thinks of. Our brain easily can come up with math facts for 1s, 2s, and 5s. So if you notice going down our quick facts, we're going to stick with a lot of those numbers. So after 4 times 10, we have 4 times 20. That's another 2. We could do 4 times 50. I don't normally do that one. I skip right over to 4 times 100. Now, what I will say is we could continue our quick facts. I always stop when we get to 1,000. So if I was continuing this, I would do 4 times 200 and 4 times 1,000. However, I know in my head 4 times 100 is 400, and that's already bigger than 236. So I can keep writing my quick facts, but I know I'm not going to use them. I am going to keep writing them just for the sake of seeing them. That's 200 and 1,000. Now, here's the best part. We're going to go through and solve it, but once we solve the first set, it's going to be really easy to do the rest. So I'm going to solve it in a different color. I'm going to solve it in green. So 4 times 0 is 0. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 5. If I don't know this, I can count by fives. 5, 10, 15, 20. 4 times 10. If I don't know what 4 times 10 is, I can go back to 4 times 1, which was 4. And I know there's 1 0 in 10, so I'm going to put 1 0 at the end. 4 times 20, I might not know that, but I know 4 times 2 is 8. So this is going to be 8 with 1 0 at the end. 4 times 100, that's 4 times 1, which was 4 with 2 zeros at the end. 4 times 200, that's 4 times 2 is 8 with 2 zeros at the end. And 4 times 1,000, that's 4 times 1 is 4 with 3 zeros at the end. Okay, so now we have our quick facts. It's a little hard to do it on my board. My board gets kind of cramped. I would recommend having these on a sheet of paper, but on my board, we've got our quick facts. Now that we have those written down, we can solve. So we're going to look at our quick facts, looking at the green, the answers. We're going to ask ourselves, which of these problems is the closest we can get to 236 without being too big? Well, 4,000, that's too big. I can actually cross that one out if I wanted. Because it's too big, I'm not going to use it at all for this problem. 800, that's too big. 400, that's too big. Oh, but 80. 80 is not big enough, but it's not too big. It's the closest we came. So we're going to use 80. So over here where it says 236, I'm going to subtract 80. I'm going to take that answer piece away. But I also have to remember, we've got our 4 here, we've got our 80 here, but this purple 20, we can't forget about him. We're actually going to write him on the other side of the bar. That's why we made the bar. On that side of the bar, we're going to write 20. All right, next, we're going to subtract. 6 minus 0 is 6. Let me see if I can find my black again. 6 minus 0 is 6. 3 minus 8, I can't do that. 2 becomes a 1. 3 becomes 13. 13 minus 8, that's 8. 9, 10, 11, 12, 13. That's 5. 1 minus nothing is 1. So my new number is 156. Looking at my options again, the closest I can get is 80 without being too big. So once again, I'm going to subtract 80. Because I subtracted 80 again, there's 80, there's 4. Can't forget about our 20 though. So we're going to write 20 off to the side. And then we're going to go ahead and solve that. So 6 minus 0 is 6. 5 minus 8, can't do it. 1 becomes a 0. 5 becomes 15. 15 minus 8, I'm going to put 8 in my head. 9, 10, 11, 12, 13, 14, 15. So that would be 7. 0 minus nothing is 0. All right, my new problem is 76. Only thing is, when I look, 80 is too big. So I can cross that 80 out. 40 though. 40 works. 40 is not too big. So now, instead of subtracting 80, I'm going to subtract 40. So we've got our 40, we've got our 4. Oh, but that 10, we can't leave him out. On the other side of our bar, we're going to write 10. Then we're going to subtract. 6 minus 0 is 6. 7 minus 4 is 3. Oh, well, 36, that's too big again. So 40 is too big. Next, we're left with 20. Okay, so we're going to subtract 20. We've got 20, we've got 4. That 5 has to go somewhere, so we're going to put that 5 on the other side of our bar. Six minus 0 is 6. 3 minus 2 is 1. That leaves us with 16. All right, so we're looking at our list. 20 is too big, but 12 works. So we're going to subtract 12. We've got our 12, we've got our 4, our 3 we don't have, so we're going to write that over on the other side of the bar. If you notice, I didn't write my bar big enough, so I'm going to have to extend him down a little bit. All right. He's now longer, we have more space. And we said we're writing a 3. Okay, now we have to solve. 6 minus 2 is 4. 1 minus 1 is 0. Remember, we're looking for a number that's as close as we can get without going over, but it can be the same as. So when we're looking, 12 is too big, 8 is too big, but 4 is the exact right option. It's not too big, it's not too small, it's exactly the same. So we're going to subtract 4. We look, we've got a 4 here, we've got a 4 here, but we're missing our 1. We're going to write that off to the side. Then we're going to subtract. 4 minus 4 is 0. Now we're done with this side because we've reached 0. If it was a remainder problem, we would be done when our number was lower than the 4. But we'll get to that on the next problem. We're almost through, but now we need the answer. So we've basically come up with all these different multiplication problems that go together to make this number. So we need to look at that side and we need to put them together. We're going to put them together by using addition. Just like we use subtraction on the getting smaller side, we're going to use addition to put all our pieces together. So that's 20 and 20, that's 40. 40 and 10, that's 50. 50 and 5, that's 55. 55 and 3, that's 58. 58 and 1, that's 59. If we wanted to check this answer, we could take 59 and multiply it by 4, and that should give us 236. I'm not going to on this one because I don't have enough room, but if I was working on this on paper, then I would do 59 times 4 to make sure that I have the right number. All right, now we're going to switch gears just a little bit, and we're going to work on a division problem that has a remainder. We're going to do the same basic steps as what we did for the first one, but that black one really doesn't erase well. I think I'm going to use a different color this time. We're going to do the same one we did for the first one, but we are going to do the end just a little different. We don't stop at 0. Okay, we have 302 divided by 5. Well, let me see if I can do this over a little bit. I'm going to run out of room. Oh man, still going to run out of room. $302 divided by 5. Notice I tried to make my bar a little longer this time, when we don't run out of room. All right, for this one, we are going to write what we call quick facts on the side. Remember our quick facts? They're all going to start with 5 because that's the number we're dividing by. So we've got 5 times 0, 5 times 1, 5 times 2. Oh, I'm going to do all my 5s going down first, and then I'm going to go through and add the other numbers. No, I'm not. 5 times 2, 5 times 3. Remember, 5 times 3 is the one that not everyone does. Then we're going to skip over to 5 times 5. Then we've got 5 times 10. This is where our pattern starts repeating. Then we're going to do another one, 5 times 20, because 2s are something our brain thinks of easily. We've got 5 times 100. And then we've got 5 times 200. Remember, when you're writing your quick facts for yourself, if you get to a fact that you know is already too big, you can always stop. For the sake of my example, I'm going to keep going till I finish. The last one I would do would be 5 times 1,000. I would never go higher than 1,000 on my quick facts. All right, now that we've written them down, we're going to solve them. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 5, 25. 5 times 10, if I didn't know this off the top of my head, I can go back to 5 times 1, which was 5, and add a 0 on the end. 5 times 20, which is 5 times 2, which was 10. We add a 0 on the end. 5 times 100, that's back to 5 times 1, which is 5 with 2 zeros on the end. 5 times 200, that's 5 times 2, which was 10, with 2 zeros on the end. And last 5 times 1,000, that was 5 times 1, which was 5, with 3 zeros on the end. All right, now that we have our quick facts, we're going to start solving. To solve, we ask ourselves the question, which one of these answers, that would be the purples, is the closest I can get to 302 without being too big? If the number is already too big, we can cross it off. So we've got 5,000. Well, that's definitely bigger than 302. We've got 1,000. It's too big. We've got 500. It's too big. 100. It's not big enough, but it's not too big. So that's going to be the one we use because it's the closest we were able to get to 302 without being too big. So over here under 302, we're going to write minus 1. Oh, I'm backwards. Hold on. I need to be using purple there. We're going to write minus 100. Now, if we look, we have our 100, we have our 5, but that 20 isn't written anywhere. So we're going to take that 20 and we're going to write him on the other side of the bar, right next to the 100. Notice I write them in line with each number that I subtract because it helps make sure I don't forget a step and I don't skip writing one of the numbers on the side. Okay, now that I have that, I can subtract. So that would be 2 minus 0 is 2. 0 minus 0 is 0. 3 minus 1 is 2. So my new number is 202. The closest I can get to that is still 100. So I'm going to subtract 100 again. Once again, notice our 100 is taken care of, our 5 is taken care of, but that 20, we haven't taken care of him yet. So we're going to write him off on the side. All right, then we're going to subtract. 2 minus 0 is 2. 0 minus 0 is 0. 2 minus 1 is 1. My new number is 102. Well, guess what? 100 is still the closest number. So we're going to subtract 100. If you notice, our 100 is here, our 5 is here, but that 20 is missing. So we have to write him on the side. All 3 pieces have to be written. All right. 2 minus 0 is 2. 0 minus 0 is 0. 1 minus 1 is 0. Now, if I look here, I'm going to go down my quick facts, and I'm going to stop when I get to the number that can go into 2. All right, so 100 is way too big. Too big, too big, too big, too big. 5 is close, but it's still too big. that leaves 0. So I can subtract 0. Off on the side, there's another 0 I need to write. 2 minus 0 is 2. Wait a second. That's the same number as the last one. Whenever you're dividing and you get down to that final number, and no matter how many times, because the only thing I could do again is to subtract 0, it's not going to change my 2. This 2, because it's smaller than a 5, would be called my remainder. So I'm going to circle that number because we're going to need to include him in the answer, and I'm going to show you how once we add up the other side of our answer. So now that we've done all the subtracting part, we want to add all of our little pieces together. So we're going to add this side. That's 20 plus 20 is 40. 40 plus 20 is 60. 60 plus 0 is 60. So our answer would be 60. And then remember that 2? We're going to do an R for remainder and a 2 at the end. So our answer would be 60 remainder 2. Another way we could write this is we could do 60 and 2 over 5. Because fractions are a form of division, we could write our whole number of 60, and this is saying 2 divided by 5 because we weren't able to finish dividing that number. Either way, this is saying the same answer. It's letting the person looking over your answer know that you weren't able to get it down to a solid number. You still had some pieces you couldn't put into groups. All right, thank you so much. Again, if you have any questions, feel free to comment and I'll try to clear them up. Thank you. Have a great day.